Hey, this is Mr. Mitchell with a video on electricity terms. Let's start with current. Electric current is the net movement of electric charges in a single direction. And electric current is measured in amps or amperes. And an ampere is 1 coulomb per second. So you have all these charges flowing in a certain direction, and the amp is how many charges flow past a certain point in any given second, because you may remember that a coulomb was how many charges flow past any given point. Now, when people talk about electricity, they talk more in terms of amps than they do in terms of coulombs, just because amps invariably has that time dimension to it. So the current, for example, in this battery flows from one direction to completely around to the next. And you can see that this is a closed path. And I'm sure you've had in previous science class about circuits have to be in an enclosed path. So if you were to break this path, take this off the end of the battery, for example, you would not have any electricity light up. It has to be in a enclosed circuit. It's the negatively charged electrons that do the flowing. However, the flow of current actually travels in the opposite direction of the negative electrons. So you have flow of electrons in one direction, and the current actually goes in another direction, which is kind of interesting. So you know how we talked about how things flow from higher concentration to lower concentration? It's true with pressure that we talked about earlier this year. It's true with something like water. If you have a higher concentration of water, it will flow to a lower concentration. The same thing is true with electricity. Electrons, these charges flow from higher concentration to a lower concentration, and that is going to be measured in voltage. Voltage is the difference in electrical charge from one place to the next. So if you have higher voltage in one section of the wire and lower voltage in another, it will flow from high to low. Voltage pushes the electricity through, and it's because of high concentration and low concentration. And it's the difference which makes the electrical charge move. Now, you can see that we also have a term called resistance. Resistance is kind of like electrical friction. Resistance often will transfer electrical energy into thermal energy. So as you have energy going through, electrons going through the wire here, you're not going to be 100% efficient. You're going to have some resistance. I'm not sure what the effectiveness of going through a wire is, electrons going through a wire, but I know it's not 100%. So you do have some friction or resistance. Now with electricity, sometimes it's good to have resistance. If you have uncontrolled electricity flowing through the wires, that can be very dangerous. So we have figured out that you can control the resistance, that you can have a limited amount of electricity going to, for example, your house. For example, in your house, if you plug up to any given outlet, it's not going to have but about 120 volts, which is the voltage. So the maximum can be controlled by having resistance. And you can see these little things that are attached with the wires here, and they control the resistance. They tone it down, which is a good thing. But you may notice that your cell phone or computer might get hot while in use. That is also known as the resistance. Now, the resistance is measured in ohms, and you can see ohms. OHM is right here, OHM is right here. So let's explain this diagram here. I have heard that this diagram is like, it explains electricity fully. You have amps, which is the current. The current is what flows through the electrical wire. The volts is what is the high concentration to low concentration, and it pushes the amps through because you apparently have high concentration on one end and low concentration on another, so volts push it through. However, ohms, which is the resistance, limits how fast it goes through or how effectively it goes through. So I think that's a very, very appropriate. We have current, we have voltage, which is potential. I'm sorry. The voltage pushes the current through, and we have ohms, which gives it resistance. There happens to be a formula for that, and it's pretty basic. The current, which is related in I, that's the current in amps, equals the voltage divided by the resistance. So it's not just going to be the voltage, because voltage is uncontrolled electricity from high to low. You have some resistance which keeps it at what the current is going to turn out to be. And that turns out to be a good thing. The one-way flow of electrons is called direct current. Now notice over here we have AC and DC. Let's explain the difference between direct current and alternating current. Direct current is the direct flow from electrons you find often like in batteries. And you had a good example back here. This is going to be direct flow. The flow of electrons is going one way. It's going to continue to go one way as long as the battery is charged and as long as you don't break the connection. But there is something called an alternating current, and most of our electricity comes from alternating current. Now, the alternating current is something that kind of needs to be explained on a different video, but just realize for now that most of our current doesn't have a direct flow. It alternates. It goes back and forth, and the current changes direction about 120 times a second. And when we get current from power plants, it goes through the lines and goes to our house, and it is alternating current in literally all examples of what goes through in most of large-scale electricity. So I hope you have learned a little bit about currents, which is measured in amps, voltage, and resistance, which is measured in ohms. Thank you.